Right, so today we're looking at solving system of linear equations by elimination. This is another technique in finding the intersection point of two linear equations. The first one was substitution, where I called it a nickname and you plug it into the other equation. This time we're trying to eliminate one of the variable terms to find the other. So let me show you what that looks like. And the same instructions are to solve this, meaning we're trying to find the intersection point. So this time I have x plus 3y equals -2. And then I have x minus 3y equals 16. Now, these two equations, you can already tell there is not an isolated variable. There is not one variable by itself on the left side of the equal sign. These are both in standard form. And what does it mean, standard form? Standard form is when you have an equation that's got your x terms, y terms equals your constant, a number. So these are both in standard form. Because they're both in standard form, you notice that your two x terms line up perfectly vertically, your two y terms line up perfectly vertically, and your numbers, constant terms, line up vertically. So we're going to do something that's not usually done. We usually do math horizontally, but this time we're going to total these up vertically, just like you did when you first started adding in elementary school. The numbers are written vertically instead of horizontally. Now, this is called elimination. That means I want to eliminate one of my variables. I cannot draw the line here and solve it. I can't. I cannot get one of them by themselves because there's two. There's an x and a y. I need to focus just on one. So part of this elimination process is you want to get rid of one of the variables so that you could focus on finding the other. And in this case, if I add them up, this would be 2x. If I add this up, that would give me a 0. And if I add these up, that would be 14. So because I can already see that right here, if I do add these up, I'm going to get a 0. That's great because that means I do not have to worry about the y's. And if the y's are all gone, I'll just have x to focus on. So I'm going to do that. And if I add these two, again, I said it was 2x. 1 plus 1 is 2. Plus 0, because that totals 0. And this would be 14. So the elimination process is wanting to get rid of one of those variables. And in this case, my y's are all gone. And so now I'm able to focus on finding that x by doing the inverse operation, which is to divide by 2. That's 1x equals 7. So I am almost halfway done. Well, I am halfway done. I got the x coordinate, which is 7. And now, remember, the problem is we cannot have two variables at the same time when we're trying to solve. But now that I don't have a variable for x, I won't have a variable for x because I can replace it with the 7. I'm going to use this first equation, and since I did have two variables and I wasn't able to solve it, if I replace this with the 7, then I'll only have a y in there. So that's what I'm going to do. So I'm going to replace that x plus 3y equals -2. All right, and just so you see where that came from, let's show you that this equation just came down here. Okay. And now my x was 7, so that's what I'm putting here. Okay. I couldn't solve it before because I can't have x and a y, but now that I know x is 7, I don't have an x anymore. I'm able to focus on y. And so I'm going to get rid of 7. Now I just have 3y equals -9. And then in doing this, you divide by 3, and we get y equals -3. And that's your solution. Okay, So what do? We vertically combined the terms. One of them gave us a 0. And once you get that 0, you do not have your y's anymore, so that you can focus on finding x. Once we found x, we knew that if we replaced this x with the 7, now our equation would only have y's in it. And then now we can focus on finding the y. Okay, so let's try example B. Example B says negative x plus 3y equals 0, and x plus 3y equals 12. And when we're doing the elimination method, you kind of want to know what you're doing before you start writing anything down. So let's focus on this one. Will I get a 0? If I add these up vertically, will I get a 0 somewhere? And if you do, then just go to it and do it. If not, then we're going to have to do something different. And I'll show you what that different one is. Some students will say, yeah, Miss Flores, you got lucky this time, right? 3y minus 3y is 0, but that's not always going to happen. You're not always going to get a term that equals 0. And in that case, we are going to do something different, and we'll get to that. So, for this one, you should have been noticing that if I add them up, these two will be 0. Negative invisible 1 and a positive invisible 1 gives me 0 x's. So in this case, my x's are gone first. Now that I don't have x's anymore, I can focus on finding the y's. Combine these terms together, that's going to be 6y. We're adding them up, okay? Combine these together, that's 12. And now when I'm solving this, divide by 6, and I get y equals 2. And this time I found my y coordinate first. And now that I know that y is equal to 2, I didn't like seeing the y in my equation because it had 2 variables. But if I can replace it with the 2, I won't get to see y anymore. So let's do that. And let's just pick the first one again. Doesn't matter which one. I'm going to take this one, and we'll use that one. So it'll be negative x plus 3 y equals 0. All right? So now that y, instead of putting a y in there, we're going to put a 2, the one we just found. And by doing that, my equation now only has an x variable, and I can focus on finding it. Before, when it was a y here, I was like, what? I can't do two variables at the same time. All right, now we got 6 here. Negative x equals 0. Now I can get rid of the 6. Addition of 6, subtracting 6. And that's going to be negative 6 on the right side. And bring down this negative x over here. Now, we're not done because that's not x. That's negative x. And I want positive x. So what I got to do is, I know this is an invisible negative 1 being multiplied. So I'm going to divide by negative 1 in the inverse operation. Negative divided by negative is positive x. And negative divided by negative is positive 6. And so that's my solution. 6, 2. All right, so let's look at example 2. What happens when you don't get that initial 0 in the elimination process? And what do you do to fix that problem? So example 2 says, or example 2a, we'll do 2 examples. 3x plus 4y equals negative 6, and 7x plus 4y equals negative 14. So as you're looking at this and you're wanting to use the elimination technique, you can't identify where that 0 is going to be, because this doesn't give you 0. That gives you 8y, and that's not what we're looking for. We're only needing to find zeros on the variable terms. So we got a problem. And to solve that problem, I say we have to make a wish. And I'll show you what I mean. And I'm going to say that I wish this was a 0. Okay? I wish I had a 0 there. Now, but I don't. Now, I need to make that wish come true. So how do I do that? Well, let's identify this as equation 1. And this will be equation 2. We're going to have to change a little bit of the problem. So looking at what I have and what I need, the only way I can get a 0 is if this was actually a positive 4y with a negative 4y. Then I would get a 0. So that's what I wish. I wish I had a positive 4y and a negative 4y. That would be great because I would have a 0. And that's okay. Once you make that wish, we got to make that wish come true. And the way we make that wish come true is mathematically change that equation. So 4y positive, that one's okay. But the second equation has a positive 4y here, but I need the second equation to have a negative 4y. So what can I do to this positive 4y to make it into a negative 4y? And you should have been thinking, I'm going to multiply that by negative 1. So I multiply this term by negative 1. I can't just change one term, I have to change the whole thing. So what you do to one part, you do to the whole thing. So I got to multiply this guy by negative 1 and this term by negative 1. So the entire second equation gets multiplied by negative 1. So now my first term in the second equation would be negative 7x, and this 14 that used to be negative will now be positive. And since nothing needed to change in that first equation, it's going to stay the same. 3x is still there, and negative 6 is still there. Okay, so now I'm ready to add up my two new equations. 3x, take away 7x, is negative 4x. Negative 6 plus 14 gives me 8. Now I only have x's in my equation. Focus on solving for x. Opposite of multiplying by negative 4 was dividing by negative 4. It gives me invisible 1x. And this gives me negative 2. So I just found my x coordinate. And now I need to find my y coordinate. Now I have 4 equations now. 2 here and 2 here. Doesn't matter which ones I choose. I'll just go ahead and go with the first one. Use that one. Initially I couldn't solve it because I had x and y. And I needed to have only one variable in the equation, not 2. But now that I know x is negative 2, I'm going to replace that x with a number so that now I'll just have a y in there. So let's go ahead and do that. 3, a bubble for my x, plus 4y equals negative 6. And so now I knew x is negative 2. My equation becomes negative 6 plus 4y equals negative 6. And now to get rid of that negative 6, I'm going to add 6 to both sides. Now I have 4y equals 0. And then I get y equals 0. And that's my solution. All right?